Okay, so we're gonna go over the review sheet. If you completed the problems, please look over your problems, see if you came to the same answer. And if you didn't, take a look of how we received that answer so you can be ready for the test tomorrow. So the first problem says simplify the following expression. Here we have 10a minus 3b minus 6a plus 8b minus a. So whenever you see simplify, we're not looking for a solution. We just want to make this expression in the simplest term possible. So usually that's what that entails is first you're going to look to see, is there anything that you can distribute or multiply? So nothing here can be distributed. So we're going to move on from this one. And then you're going to ask yourself, can I combine any like terms? So if I look at these, I notice that there are like terms here. So what I'm going to do is I'm going to circle my like terms. So I have 10a. And what else is like terms with 10a? Anything with the same variable. So 10a is a like term with negative 6a. Are there anything else? Yes, there's negative a. So let's see what happens when I combine these three like terms. I have 10a. Now don't forget that sign. Notice how I circle that sign with it. Minus 6a minus a. Now these are all our a terms. So we want to combine them. So here we have 10a minus 6a, that there is 4a, and then minus a. Remember, there's a 1, an invisible 1 in front of that a. So that's negative 1a. So 10a minus 6a is 4a, minus 1a is 3a. Now, what about our other like terms? I'll use a different color for that one. We have negative 3b, and we have positive 8b. So these are like terms because they both have b. So let's combine these as well. We have negative 3b, and then we keep the sign here. So that's plus 8b. We're going to do plus 8b equals. So negative 3b plus 8b. If you're not comfortable with this, you can try it in the calculator. But this is going to give you 5b. Now, to simplify the expression, we have to write it as an expression. So we have here 3a, and then this is a positive 5b. So 3a plus 5b. And that is your simplest terms. There's nothing else you can combine. There's nothing we can plug in. This here is our simplest terms. Next, number 2. Evaluate the expression if a equals 4 and b equals 6. So remember to read your directions. I noticed in class some people skipped over this. So they're giving us the information here that a is 4 and b is 6. So what they want us to do is plug in these values and then use the order of operations. We're going to use PEMDAS to evaluate. So first, we're going to rewrite the expression, but wherever we see a, we're going to plug in 4. So I'm going to make a 4, red term over here. So 5 times 4. Remember, when a variable and number are next to each other, that's multiplication. So 5 times 4 minus 3. Now we have b. I'll do this in blue. B for blue, we'll do blue. So now b is 6. I'm going to plug in 6. Negative 3 times 6 plus 15. Now we're going to do PEMDAS to evaluate. Is there any parentheses? Well, I see parentheses, but there's nothing that I can do inside of them. They're here and they're here, but there's nothing I can do inside of them. So I'm going to go on. There's nothing I can do inside the parentheses. Are there any exponents? I don't see any exponents anywhere. So There are no exponents. Now multiplication. Now we said when we have two terms next to each other without any signs, that means that they're being multiplied. So what is 5 times 4? That gives us 20. There's some more multiplication happening here. We have -3 times 6. Don't forget your signs. -3 times 6 is -18. So this becomes 20 minus 18. And then don't forget to bring down that 15, plus 15. Now, if we do this, 20 minus 18, that is 2. Then bring down that plus 15. Now, 2 plus 15 is 17. When you evaluate, for A is equal to 4, B is equal to 6, the expression is equal to 17. Number 3, evaluate the expression if A equals 6 and B equals 8. Now, this one is very similar to the one we did in class today. So same thing, we have, I'll do it in red, A is 6 and B is 8. So wherever we see A or B, we're going to plug in those values. So we have 10 minus 4 times, well, A is 6. 6 minus, now our B is 8. 6 minus 8, close those parentheses to the second power. Now, everything's plugged in. Again, we're going to follow PEMDAS, the order of operations. Is there any parentheses? Yes. Is there anything that we can do inside the parentheses? Yes, we can do 6 minus 8. So we're going to, if you do 6 minus 8, you get -2. Now, don't forget to bring down everything else. We have to the second power, we have 10 minus 4. So parentheses, is there anything I could do with that -2? There's nothing that I can do inside of the parentheses. So we're done with the parentheses. Are there any exponents? Now, be careful here. A lot of people make this mistake. We are following PEMDAS, so we're not doing 10 minus 4 yet. And we're not doing 4 times -2 yet. We have to evaluate for the exponent. So here we have -2 to the second power. Now this means -2 to the second power is the same as saying -2 times -2. Now a negative times a negative gives you a positive, and 2 times 2 is 4. So -2 times -2 is +4. So 10 minus 4 times that +4 that we just evaluated. Now remember, we did parentheses, we did exponents. Now we do multiplication. Do not do 10 minus 4 first. So we're going to multiply -4 times +4. -4 times +4 is -16. We're going to bring down that 10. Now we have 10 minus 16. That gives us an answer of -6. If you didn't get that, please double check, see where you went wrong, and we'll prepare for tomorrow. Number 4, the solution to -3 times 2 minus 6x is equal to 5x plus 20. So something I want to highlight and note is that when you see they're asking you for the solution, they're asking you to solve. They want you to solve for the variable. And that means our goal is to isolate the variable. So the first thing I see that we can do is we can simplify this a little bit by multiplying and distributing -3 times 2, that's -6, and -3 times -6. Now be careful, that's -3 times -6x. So that gives us positive, not 6x, positive 18x is equal to 5x plus 20. Now we have an expression and we have this equation and we want to get the variable isolated. We want to quarantine that variable. We want to get it by itself. So I know I told you guys, whenever we have this, we want to draw two lines by the equal sign so we know our left side of the equation and our right side of the equation. I'm also going to label my terms. So this is my constant. -6 is a constant. 18x is a variable term. 5x is a variable term. And 20 is a constant. Now we want to get all the constants to one side and all the variables to the other side. It doesn't matter which side you do it, as long as you get all the constants to one and all the variables to the other. So I like dealing with positive numbers. So what I'm going to do is I'm going to get all the variables to the left side. So I already have 18x over here. So I'm going to bring the 5x to the other side. Now, in order to do that, I want to combine them. So when I cross this equal sign, this 5x has to change signs. So we're going to do the opposite. Since this is positive 5x, we're going to minus 5x to both sides. We subtract 5x here, and we are left with -6 plus 13x is equal to 20. Now, if I want to relabel my terms, I can. This is my constant, this is my variable, and this is my constant. Now I have all the variable terms on the left side. Now I want to get all the constant terms to the right side. So what I'm going to do is I'm going to, since I want this -6 to go on the other side of the equation, I'm going to add 6 to both sides. I do the opposite of that -6. -6 plus 6 cancels out, that equals 0. And that leaves us with, bring down that 13x is equal to 26. Now, did we solve for the variable? Nope, because we still have 13x. We don't have that variable by itself. Now here, we're finished with the adding and the subtracting. All the variable terms are on one side and they're combined. All the constant terms are on the other side and they're combined. So we're going to take a look at this. We have 13 times x is equal to 26. So this is saying 13 times some number is equal to 26. So we're going to do the opposite. If we divide 13 to both sides, 13x divided by 13 is 1x, or we can just say x, and that's equal to 26 divided by 13 is 2. If you want to check your answer, you can always plug it back in. Now to check it, we'll do this really quickly. Wherever we see an x, we're going to plug in the value of 2. -3 times 2 minus 6. Now we have an x value, so we're going to plug in 2. Equals 5. We have another x value, so we're going to plug in 2 again. Plus 20. So start inside the parentheses. We have -3 times 2. So again, we multiply first. We have -6 times 2. That is -12. So 2 minus 12 is equal to 5 times 2 is 10 plus 20. Here we have -3. 2 minus 12 is -10 is equal to 10 plus 20 is 30. And now we have -3 times -10 is positive 30. And 30 is equal to 30. That means our solution is x equals 2. Number 5. So again, the solution to 4 times x minus 7 plus 5x is equal to 7x plus 12. This one is very, very similar to what we did in the last one. There's just one extra step. So we're going to start by multiplying. So we're going to multiply and distribute, oops, wrong thing. Multiply and distribute 4 times x, that gives us 4x, and 4 times -7, that gives us -28. Then we're going to bring down everything else. Plus 5x is equal to 7x plus 12. Now before we start solving, we're going to make sure that we simplify and combine all our like terms on the same side of the equation. So I'm going to draw these lines down right here. But I noticed that on the left side of my equation, I have 4x and 5x, or positive 5x. That means I can combine these. So I'm going to do, what I'm going to do is combine these. I get 4x plus 5x. That is 9x minus 28 is equal to 7x plus 12. Now I'm going to get all my variable terms to the left side. If you want to label your variable terms, you can. But I'm going to subtract 7x to both sides to get all my variable terms on the left side. 7x minus 7x is 0, so they cancel out. 9x minus 7x is 2x. Bring down the -28 is equal to, we bring down the 12. Now we're going to add 28 to both sides. We get all the constants on the right side. So it's -28 plus 28, they cancel out. We have 2x is left on here is equal to 12 plus 28 is 40. We're going to divide by 2 to both sides. So x is equal to 20. Now you can check by plugging this in. Because of time, I'm going to move on. Okay, now this is the one we're all dreading. This is the fractional one. So we're going to do this just like the way we talked about them in class. So we're going to start with the same concept. You have 2/3 times x plus 4 equals x minus 7. So just like the last problems, you're going to distribute 2/3 times x and 2/3 times 4. So if you're not comfortable with fractions, remember, if you have any whole number or any number by itself and you want to turn it into a fraction, just put it over 1. So 2/3 times x is equal to, you multiply the numerators, you multiply the denominators, you get 2x/3. Now we're going to multiply the same thing times 4, and you're going to get positive, because it's both positive terms, positive 8/3 is equal to x minus 7. Now we said that when we're dealing with fractions, we want to get them all to have the least common denominator to be the same. So since the denominator here is 3 and the denominator here is 3, we want to give these terms the denominator is 3 as well. So remember, to turn it into a fraction, just put it over 1. And we want the denominator to be 3. So how do I turn 1 into 3? I multiply it by 3. So I multiply denominator by 3. And when I multiply denominator, I do the same thing to the numerator, times 3. I'm going to do the same thing over here. Multiply this by 3, multiply denominator by 3. So we can all have 3's in the denominators. So what does that leave me with? So if I bring everything down, I'm left with 3x/3 minus 7 times 3 is 21/3 is equal to, now bring down everything on the right side, 2x/3 plus 8 over 3. Now, because they all have a denominator of 3, usually this means we can multiply 3 to both sides, and it's going to cancel out all the denominators. But the easy way I told you guys to remember is if they all have a denominator of 3, we just cross out all the denominators. And now we're left with, I'm going to bring it to the top so we have more space. We're left with 2x plus 8 is equal to 3x minus 21. Now we have to solve. So I'm going to draw a line all the way down. Again, the goal is to get x by itself. I like getting x to the left side, or the variable to the left side, and the constant to the right. So we have a variable term, a constant, a variable term, a constant. Now, I like to move all my variable terms to the left side. So I'm going to move this in 3x over here, but in order for me to cross that line, I have to do the opposite. So I'm going to subtract 3x here and subtract 3x here. 3x minus 3x cancels out. I have 2x minus 3x is negative 1x, or we can just say negative x, plus 8 is equal to, this canceled out, so I'm left with negative 21. Now I subtract 8 to both sides because I want all the constants together. We have negative x is equal to negative 29. Now we're going to divide, because we have negative x. We want to have positive x. We're going to divide by negative 1 to both sides. So when you divide by negative 1, x is equal to positive 29. Number 7. Okay, something similar to this one. You might want to grab a calculator if you need it. So here we're going to go. We're going to start by distributing again. We have 2 times x, that gives us 2x. Distribute again, 2 times negative 4, don't forget that sign, that is negative 8, is equal to 3.6 times x, that is 3.6x. Distribute again, 3.6 times 2. So when you multiply that, it's okay if you need to use a calculator, but 3.6 times 2, did I say 3.6? Yes, 3.6 times 2 is 7.2 plus 7.2 plus 2.44. Bring down everything. Now, draw those lines. It's following the same steps. On the left side, there's nothing I can simplify yet, but on the right side, if I take a look carefully, I have, no, not this. I have 7. Oh, whoa, it didn't erase. Okay, I need to erase it again. (3.6x plus). Okay. On the right side, I have these like terms, which is positive 7.2 and positive 2.44. Now, when you add these together, you're going to get 7.2 plus 2.44, get 9.64. It's a positive, so you have that, and you bring down everything else. 3.6x is equal to 2x minus 8. So I like having my constants on the right, so I'm going to add 8 to both sides. That's going to be 2x is equal to 3.6x plus 17.64. Now I'm going to subtract 3.6x to both sides. I want all my variable terms together. 3.6x, and that's going to give us negative 1.6x is equal to, this cancels out, we have 17.64. Because of space, I'm going to move this. I'm going to move this to the top. And we're going to continue from over here. Now I divide both sides by negative 1.6x, sorry, negative 1.6 because we want x by itself, negative 1.6. So 17.64 divided by negative 1.6 is x is equal to negative 11.025. Next question, number 8. So another fractional one. Which value of x makes x minus 7 over 3 plus 5 over 2 equals 23 over 6 true? So here, again, we're looking for the value of x. We want to know what's the value of x. So as we said with fractions, I see a lot of fractions here, and we want to get a common denominator. So the first thing we're going to do is we're going to look for the least common denominator, the LCD. Or you can call it the LCM if you like, the least common multiple. And all the denominators we have is 3, we have 2, and we have 6. So let's list some multiples of 3. That's 3, 6, 9, 12. Let's do 2. We have 2, 4, 6, 8. And 6, we have 6, 12, 18, 21. So if I look at these, the least common denominator they all have in common is 6. So I want to turn all of the denominators into 6. So I'm going to, in order to turn 3 into 6, I'm going to multiply 3 times 2. Let me write it like this. So 3 times 2, and what you do to the denominator, you do to the numerator. In order to turn 2 into 6, I'm going to multiply that by 3. And again, to the denominator, you do to the numerator. And then the last one is already 6, so I can leave that one alone. So we should have 3 fractions. They should all be over 6. And we know this one is equal to 23 over 6. Now what's on the fractions? Let's take a look. So when we do 2 times x minus 7, we're going to still multiply that by everything in that numerator. So we're going to distribute. That's 2x minus 14. And then we have 5 times 3 here. 5 times 3 here. So we're going to do 15 over 6. It's a positive 15. So it's going to be positive 15 over 6. Now again, since we have all the denominators are 6, we can cancel them out. Because if we multiply 6 to both sides, they all cancel out. And now we're left with 2x minus 14 plus 15 equals 23. I have like terms. Our goal is still to find the value of x. So I have like terms. I have negative 14 and positive 15. If I combine those, I get, If I combine these, I get positive 1. Bring down everything else. We have 2x plus 1 equals 23. We're going to subtract 1 to both sides. We want to get the variable by itself. We have 2x is equal to 22. Divide by 2 to both sides. And that leaves us with x is equal to 11. Number 9, we'll have 2 more questions. Number 9, okay, Jackie solved linear equation 6 times x plus 3 minus 10 equals 20. So she made an error between which lines? Explain your answer. So if we're taking a look at this, in line 1, she rewrote the problem. 6 times x plus 3 minus 10 is equal to 20. And line 2, something changed. What changed? This 10 is gone, and this 20 now became 30. So what did she do? She added 10 to both sides. So, and you can do that to get the variable by itself. So now 6x plus 3 is equal to 30. Now line 3, she has 6x plus 3 is equal to 30. So the parentheses are gone, but how did she get there? She multiplied 6 times x, and she got 6x, but she did not multiply 6 times 3. Remember, you have to distribute. So her error is between lines 2 and 3. She did not distribute to get 6x plus 18, what it should have been. She has 6x plus 3. And last but not least, ooh, this is the fun one. Solve algebraically for x. We have 5 over 6 times x plus 7 plus 1 over 6x equals negative 5 over 3x plus 5. This is a tricky one, but this has been on the Regents before, and we're going to do this together. So still, we're going to follow those same rules we did last time. 5 over 6 times x is 5 over, sorry, let's do it. We turn these into fractions. That's 5x over 6. 5 times 7 over 1, oh, sorry, 5 over 6 times 7 over 1. That gives us plus 35 over 6 plus 1 over 6x is equal to 5 over 3x plus 5. Now, something that it's good to know is that when you have 1 over 6x, another way you can write it is 1x over 6. Same thing for here. Instead of 5 over 3x, you can write it as 5x over 3. Now, it looks like we have a common denominator here that seems to be a pattern, and that is 6, 6, 6. So we want to make all the denominators 6. So what we're going to do is we're going to multiply this denominator here. It's 3. To get that to be 6, you multiply by 2. And what you do to the denominator, you do to the numerator. Don't forget that step. A lot of people do. And 5 is 5 over 1. So we're also going to multiply. We're going to multiply these both by 6 to turn that denominator to 6. Multiply it by 6. So let's rewrite our new expression. We have 5x over 6 plus 35 over 6 plus 1x over 6 is equal to 5x times 2 is 10x over 6 plus 5 times 6 is 30 over 6. Awesome. Now we have all the numerators, all the denominators are 6. So all we have to do is cancel them out, because if you multiply 6 to both sides, they all cancel out. We have 5x plus 35 plus 1x is equal to 10x plus 30. Now all we have to do is solve for x first. Again, combine your like terms. We have 5x on this side and 1x over here. And since that's the only thing on this side of the equation, that's the only thing we can combine so far. So that's 6x plus 35 is equal to 10x plus 30. Now, I like dealing with the variables on the left. If you want to put the variables on the right, you can. So I'm going to subtract 10x from this side, subtract 10x from that side. We're left with negative 4x plus 35 is equal to 30. What I'm going to do over here is is I am going to give some space over here, and I'm going to move this to the top over here, just so we have some more space. So this is going to be moved up here. I could do it over here, actually. So we're picking it up over here. Draw these lines down. So now we're going to subtract 35 to both sides because we want all the constants together. This gives us negative 4x is equal to negative 5. Divide by negative 4 to both sides because we want x by itself. And now we have x is equal to, oh, if we have a negative 5 over a negative 4, we can, that's a negative divided by a negative. So this could be 5 over 4. Or if you want to divide that into a decimal, it's 1.25. Either or of these answers would suffice. Oops. And there you go. That's the review.